Alright, so for this lesson, we are moving into Chapter 1, Section 2, and we have 4 objectives. So the first one is to be able to construct and interpret both dot plots and stem plots. So we're moving into quantitative data in Chapter 1, Section 2. Also to be able to describe the overall pattern and look and see if any outliers exist. Be able to compare the strengths and weaknesses of each type of graph, which we've been doing, and then compare distributions of two or more graphs. So this is what we're going to be working through today. So go ahead and pause the video and write your objectives. So by the end of this lesson, you should be able to answer these questions about dot plots and stem plots. Alright, so I just want you to look at this data and ask yourself, what do you see? So I have a sample of 14-year-olds from the United Kingdom. They were randomly selected, and here are the heights of the students in centimeters. So I just want you to look at that and answer the question, who do you think is taller, boys or girls? So just looking at the raw data. So this section is pretty heavy in vocabulary, but some of it's probably already going to be familiar to you. But these are the vocabulary words we're going to work throughout this lesson. Alright, so a dot plot, by definition, is one of the most simplest graphs. You can see individual values strictly on a number line. That's what a dot plot is. So we're going to make a dot plot of this information, which is the number of goals scored by the U.S. women's soccer team in the 12 months prior to the 2012 Olympics. So the first thing that I need when I'm creating a dot plot is I need a number line. Alright, and then I need to look at my lowest number and my highest number. So I see that my lowest number is 0, and my highest number is 14. So my number line needs to go from 0 to 14 evenly spaced. Alright, so once I have my number line evenly spaced out, I simply put dots where the different data points fall. Alright, so you can see that this isn't exactly perfect, but you can see the general distribution of these 25 goals scored in a month. And I can see very easily that 4 is the most, and then 2 and 3 are the next. The biggest issue with a dot plot is you want to make sure that everything is on the same level when it's the same amount. Because if I don't make it even, then it's going to be hard to see that 4 is the most if these values aren't going to be similar. So a dot plot, pretty straightforward, and I can see that I have 2 that were kind of high months that didn't really follow the pattern of the rest of the months. Alright, so when we describe the overall pattern, we are looking for 4 things right now. So we're looking for the shape, which is described as roughly symmetric, skewed right, skewed left, or uniform. So we're going to use one of those 4 descriptions. The center is basically estimating, and we're going to talk later about a more specific way to calculate the midpoint. But right now we're just estimating, so we're looking at it and we're kind of guessing. The spread, which is simply the range of the data, and then outliers. Do any individuals fall outside of that overall pattern? So these are some questions that I kind of think through when I'm trying to determine the overall pattern of a distribution. So when I'm thinking about shape, I'm thinking about, is it symmetric, uniform, or skewed? How many modes? And so a mode is, we know, the number that occurs the most. So are there some peaks, which the mode will identify with a peak? So does my distribution kind of go up, go down, and then come back up? Are there significant clusters, and are there any significant gaps? Then when I talk about the center, I'm looking for the midpoint or whereabout. And again, the center is just an estimation right now. We will come up with an actual formula later. And then what does the midpoint mean in context? So once I find it, what does that mean for that data? Spread, what's the span of the data? So it goes from the lowest to the highest. And then outliers. We're going to come up with an actual formula for calculating outliers later on. But right now we're just kind of eyeballing it and guesstimating if there's anything that kind of falls outside that overall pattern. So these are different shapes that we talked about, and the 4 that we're going to use the most are going to be the symmetric, which we call a bell shape, and we're going to deal a lot with the bell shape. This is symmetric. It starts out small, it peaks, and then it goes back. And the big thing with it is that it's basically a mirror of itself. So if I drew a line right down the middle, these points are going to roughly match up. And now for skewed, skewed always follows its tail, okay? So when I look at this, if I took a symmetric pattern and I added some data points out here, it's going to pull that shape out to the right, and so those outliers that exist, or those data points that are significantly higher than the majority of the data, are what pull that tail out. And we always describe skewed based off of where the tail is. So if the tail is to the right, it's skewed right. If the tail is to the left, then it's skewed left. So we're always looking for, is it symmetric, is it skewed left, or is it skewed right? And then sometimes we end up with this uniform, okay? So uniform is where there is no small data and large data. It pretty much all the data falls within the same value. So when we're talking about shape, those are the things that we're going to be using. We're going to talk about, is it skewed left, is it symmetric, skewed right, or uniform. Those are the 4 terms that you're going to use most. I do want to show you bimodal, 2 modes, things like that. So bimodal, so mode is the number that occurs the most. So this is a 1 mode, meaning it has 1 peak. Bimodal means that it has 2 peaks. So I can see 2 peaks skewed left, 2 peaks that's symmetric, 2 peaks that are skewed right. And then these left tail extremes, right tail extremes, that's where we just have outliers. So they're going to be still skewed left and skewed right. But the biggest thing you need from this are these 4 to be able to recognize that shape. Alright, so go ahead and pause the video and see if you can describe the shape, the center, the spread, and whether or not there are outliers, and if so, which ones. Alright, so hopefully you were able to see that this data, because of these 2 out here, are really skewed right. So that tail is pulled out to the right because of those 2 far out data points. The center, when I look at it, about half the data is here and about half the data is here, so that would put my center at about 3 goals per month, because we always want to talk about it in context. The spread, the data varies from 0 to 14 goals. And there appears to be 2 outliers at 13 and 14 goals, because if the center is about 3, 13 and 14 are really far away from that center, so that would indicate that they would be outliers. So our objective, continuing with the things we've been doing, is to be able to compare the strengths and weaknesses. So the advantages of a dot plot. It's really easy to identify the overall shape and to see outliers. It's very visually easy to identify. It's easy to make. It's easy to understand. And a dot plot can display both quantitative and categorical data. The disadvantages are, as you learned in your summer project, it is not ideal when I have 30 dots I have to put up or 100 dots. So if there's large quantity of data, a dot plot is not going to be something you want to make. And then there is no frequency axis, so that y-axis. So if I want to count how many are the most, I'd have to count all those dots. It doesn't have that specific frequency like our bar charts did yesterday. Alright, so we just covered a bunch of objectives. So we talked about dot plots. You can construct and interpret. We talked about the overall pattern and looking for outliers, and then we talked about the strengths and weaknesses of a dot plot. So go ahead and pause the video and in your notes have an interaction. Remember, this is something that needs to be meaningful to you. It's kind of a summary of what we've done. It's, do you have any questions? What are you going to need to remember when you go to study for this section? Or at the end, when you're studying for your final, what are some things that you're going to need to remember when it's been 3 months since you've talked about this? Alright, so a stem plot. A stem plot, you should remember from your summer project, is going to be that stem and then that leaf. So when I have a bunch of data, it allows me to quickly put data into a graph. So the key with a stem plot is that I separate each number into a stem and a 1-digit leaf. And that's really, really, really important, that my leaf is only 1 digit. So whatever happens after that line where the stem is needs to just be 1 number. And we're going to use the same data that we had from the beginning of the lesson where we talked about the students and their heights in centimeters. So we're going to create two stem plots of the females and of the males and their heights. And this will help us answer that question of who's taller. So before we get started in creating, I have some hints because a stem plot can be a little bit tricky if you have some unique data. So the kind of rule of thumb is that I have a minimum of 5 stems. So when I'm talking about stems, I'm talking about this right here. Now obviously not every data point is going to fall, or not every data set is going to give me that, but I always want to try to get as close to 5 or more stems, which are these numbers right here. Split stems if the data set is too small. So if you look, this was my original stem and leaf plot, and I had a tens and zeros, or tens and 20s, essentially. Over here, if I look at my key, line 1 means 11. So I can't really see any patterns in this. I can't really see, it looks uniform to me. So what I want to do is split the ones into 10 through 14, because that's 5 numbers, and then 15 through 19, which is 5 numbers. So essentially I'm taking these 10s and I'm splitting them into 2 10s and 2 20s. So now I can see that this is a little more symmetric of a pattern because I've split those, because these stems, 2 stems is too small. Also round the data if the span is too large. So when I look at this set of data right here, I'm going from the 491 all the way up to 684. That's a lot of stems to do 490, 500, 510, 520, 530, 540, and all the way up to 690. Or I'm sorry, 680. So I want to round the data. So right here, I would have the 400s, the 500s, the 600s, the 700s, and this means 49 means 490. So I've essentially rounded all these to the nearest 100. So 608 would be rounded to 600, so that's just a 0. 597 would also be rounded to 600 because I'm rounding to that nearest 100. We're not going to do a ton of rounding, but I just want you to know that that also exists. And then always make a key. So if you notice, if I looked at this, I might think 49 means 49, but in this case, it actually means 490. Alright, so go ahead and pause the video, and I'd like you to make a stem and leaf plot for both the male and the female. Remember, keep those hints in mind that if I don't have enough stems to get close to 5, then I might want to split into like 150 through 154 and 155 through 159. Just a hint. So hopefully your stem and leaf plots look similar to mine. I can see that the males span from 151 up to 187, and the females from 152 to 169. So I can see that there's a larger span here. The females are more clustered down in the 150s and 160s. So if you notice, instead of looking at a set of data, once I make a graph of it, I can kind of interpret the information more. So I can answer this question, who's taller, boys or girls? Alright, so I'd like you to pause the video and describe the overall pattern of each distribution. So looking at males, what's the shape, center, spread, and are there any outliers? And same thing for the females. Alright, so hopefully for the males you are able to see that it is roughly symmetric. So if I drew that bell curve, each side pretty much mirrors itself. The center is at about 167 centimeters, which if you have anywhere around there, because this is an estimate, but I just found the midpoint of that data. The data vary from 151 centimeters to 187 centimeters, and there do not appear to be any outliers. So there aren't any students who are really, really tall than the general pattern of the class, and not really, really short. So when we skip over to the females, I put for the shape skewed left with a question mark, because if you look at it, it's not really symmetric. There's no mirroring. There isn't really outliers to pull that tail to the left, but if you look at that general shape and I kind of start to draw that bell curve, it appears to be left if you follow that pattern. So this one's kind of hard, and that's why I put a question mark there, is because it's not really symmetric and it's not uniform, so I'm going to put skewed left with a question mark there. The center, so when I look at that, the center appears to be at 162, so I kind of found the midpoint, and it was right here. So halfway between 161 and 163 would be 162 centimeters. The data vary from 152 centimeters to 169 centimeters, and there do not appear to be any outliers. There's no students that really depart from the overall pattern of the female heights. So, with that being said, let's go back to our original question, who's taller, the males or the females? So now that we've kind of identified the overall pattern, can we use that information? So when I look at it, my inclination when I look at the center, 167 to 162, is indicating that the males might be taller. When I look at the distribution, I can see that they spread out a little bit more because these are side by side. So let's look at another kind of stem plot that will help me see it even better. So this is called a back-to-back stem plot. So if you see, I have my male data over here, which we've seen, and then my female data I took and I just put it on the other side. So it still follows that same pattern. However, if you notice, this right here means 152. I should have a key in here. And then I need to also put so I can see that that line tells me where the stem is, and then the leaf tells me what the ones digit is. So when I look at this back-to-back stem plot, and I want to see who's taller, I can very easily see on this graph that those males are going to be taller than this cluster of females. Overall, they're going to be taller. Now, there is a little bit of caution with a back-to-back stem plot. When we look at the right-hand side, that's going to be easy to read because it follows what we're used to. We see this as a number line. If I were to turn this number line this way, I could see that I have 151, 154, and make it kind of a dot plot. Now, the female side, a lot of students, if they were to describe this, they might describe it turning it this way, but you want to think of it, this is still a number line where it goes from 15 to 18. So these numbers, if I were to make a number line of it, those numbers are still going to be over here, 15. These are my higher 15s, these are my low 16s, and these are my high 17s. So your inclination might be to turn the number line like you did with the males and turn it this way, but that would give you a very different view. You want to keep this in mind, that this is my number line. So I want to keep the 15s, the 15s, the 16s, and the 16s, so that when I go to describe the left-hand side of a back-to-back stem plot, I want to keep in mind where are the small numbers and where are the large numbers. And we'll talk more about this, but I just want you to be careful with a back-to-back stem plot. Interpreting the right-hand side isn't difficult. It's the left-hand side that you really have to keep in mind. Okay, where are my low numbers? Where are my high numbers? All right, so advantages and disadvantages of a stem plot. So my advantages, it's really easy to see overall shape and outliers, kind of like the dot plot. It's fairly simple to make. It's compact, so it's a lot less than a dot plot because I'm writing those digits, and it's more compact. I don't have to stack them evenly. I do have to make sure they're spaced out evenly, and it can handle large sets of data. So the disadvantages, it can be confusing to read, especially that back-to-back stem plot, and I can only use quantitative data with a stem plot. I'm not going to be able to use that qualitative or those categorical for that. All right, so we have completed all of our objectives. This last one was specifically about stem plots, so being able to construct, interpret, and describe the pattern of a stem plot. And then we also talked about the strengths and weaknesses of that stem plot. So go ahead and pause the video, and in your notes, I need you to have an interaction. So summarize what we did, write yourself some notes, kind of write any questions that you have. What are you going to need to remember, if there's any steps, whatever you need to do to make sure that your notes are something that you can study from. And as always, just here's the vocab with the definitions. All right, I'll see you tomorrow.